Hi, we're going to do the lab on energy graphing, and so I want to take you through the setup because we're going to be using Capstone. I want to teach you a few tools and techniques to using Capstone. So we're going to use a smart card again, and in this lab it says determine the relative rates of change of energy, the different types of energy for a car moving up, then down. So the motion of the card is just, you can start at the bottom of the incline, and you're going to get a bit of shove up and have it come down. Okay? So small shove, it doesn't have to go all the way to the end of the track or anything like that, that's fine. So we're going to open up Capstone, and I'll show you how I want you to set that up, or how you can set it up for it to be most useful. This is going to be a real quick data collection. We're only doing one set of data because Capstone just captures so many points with these smart cards. So the first thing that you're going to want to do, you need to know the mass of this cart and you need to know the incline of your ramp. So do that. You need to figure out the incline of the ramp. You can use some trig if you want. That's probably the easiest way to do it. And you want to go use a balance and get the mass of the cart. Those two pieces of information are important. So then you're going to select your smart card, right, like we've done before. If you don't remember how to use the smart card, please feel free to go look that up. I'm going to put in a single data table, and this is going to be where all my information is going to begin. So I need a couple of things. So I'm going to want to record the position that it's moving up and down my incline, and I'm going to need to measure velocity. All right, so a couple things you want to do is you want to change the position sensor's sensitivity to 50 Hertz. I think that would be a good thing to do. And then when you're ready, you're going to press record. And you may want to practice a couple times to get this to go all the way up and all the way down without going off the ramp. But if it doesn't go all the way up, it's fine. It really doesn't matter. So you want to press record, give it a shove. See, mine went about halfway. Stop. And I missed. So hopefully you'll have more than one person so you have some help doing this. So once you've got this set of data and you're happy with your data set, now comes the work, right? This is the analysis. So you've got your position and you've got your velocity. So I want to show you some cool things that you can do with Capstone that makes it even easier to use than Excel. Let's add another column. So I'm using this to add columns, and I want to create a new calculation. And this calculation I want to be UG, I want this to be gravitational potential energy in joules. And then next to it I'm going to put another calculation, and that'll be kinetic energy in joules. And you'll see it gives you kind of like, you could put in a formula, you can either type it in here or we'll put it in later, it's fine. Now I want to put in another one, and this is going to be another calculation. This is going to be my total energy in joules. So let's start with that. So first thing, so all of these are calculations. How do you tell it what calculations to do? So there's this calculator here. Now if you open that up, you'll see your values here that you put in for the columns. And you're going to tell it, just like you do in Excel, what you want to calculate. So this is kind of neat because here, you know the formula is mgy, but so what are the values? So you need the mass. So I'm going to make something up because I don't have a scale here. So if it's 500 grams, I put 0.5 kilograms, and I know that it's 9.8 for G. And then what do I want as my position? So my position is going to actually be a measurement value, right? What my position along that incline, but it's going to be times sine of the angle. So make sure you measure what your angle is. So let's say my angle was 10 degrees. Make sure if you're doing a sine function, you tell it you want it in degrees, right? And now that's going to be it's going to do that calculation for you. So we're going to do that for each one. So this is 0.5, because it's 1/2 times m, right? So if mass is, I'm saying the mass is 500 grams, and then you're going to do times velocity. So again, velocity is a measurement, so I'm going to go into my measurements. That's what this little triangle is, and I'm going to tell it to use the velocity that we measured. Done. And then the total energy is going to be the potential energy plus the kinetic energy. So I'm using these calculation columns. And now if you go over back, if you close this calculator, you'll see all your columns are populated. So right now you only have one sig fig in these, and you really should fix that. So I'm gonna expand that out to like 5 places just so I can see the changes that are happening. Otherwise it really rounds too much and it looks like there's no real change going on. So we've got these calculations. So you can do this for as many calculations as you want, you know, depending on what graphs you need to make. So you can continue to add columns with more data, more calculation columns. And then now you don't have to put it into Excel. You just have to like copy and paste it or something like that. So now I'm going to make a new page. See this button here is a new page because I just don't want to squish too much. And I'm going to put in some graphs. So I'm going to put in a graph of, we want energy versus time. So we'll do potential energy versus time. We're going to do kinetic energy versus time. And we're going to do total energy versus time. And so we'll have these values here. And once you're done with this, we don't need, so I'll get rid of that. Let's delete that display. So we have 3 graphs. And what you can do is you can look at your trend line. So you can look at those rates of change by putting a fit on it. So you got to find the fit that really works well for it. So you may also find that you might want to get rid of your last, see that little bit at the end where I neglected to catch it? It's a much better fit now. So I'm going to omit that. So that's what the highlighter button is for. If you are still having trouble seeing what's going on, you are welcome to put these each on separate pages. But we're really looking to compare this A factor. This is the rate of change, right? That's going on here, and compare it to your rate of change that's going on with kinetic energy, and then look at what's going on with your total energy.